Hey guys, welcome to CPM 2. This is Module 2, Lesson 1. We're going to solve equations using the addition and multiplication property. So it says first, let's recall the difference between an equation and an expression. This helpful hint says, simply stated, an equation contains an equal sign, while an expression does not. Also, we simplify expressions and solve equations, and it is good to know the difference of these. Simplify expressions, solve equations. So you have some examples here of what an equation is, and then some examples here of what an expression is. It's right here in blue as to what the difference is. These all have equal signs in these equations. These expressions here don't have any equal sign at all. So objective A, identify solutions of equations. Example 1 says to determine whether 1 is a solution of the equation. So what that means is you need to use this 1 here and plug it in. My variable here is x. So you're plugging this in as if x equals 1. We're wanting to know, does this equal? You're going to know if this equals or not if this side here equals the same as this side here. So if we get 8 equals 8, then that's yes, this is a solution. If you get any other number equals 8, then it's no, not a solution. So, since my x is 1, plug this in. So I've got -4 times my x is 1. So 1 minus 3. And we're trying to figure out, does that equal 8? So, order of operations. That is your please excuse my dear Aunt Sally. We have some parentheses. So, 1 minus 3 is -2. Bring down your -4, your equals, and your 8. So then -4 times 2 is 8. Negative times negative is positive. So in this one, we do get 8 equals 8. So then determine if it is. Yes, it is. So yes, 1 is a solution. So B, same thing. Determine whether -3 is a solution to the equation 5m plus 9 equals 2m plus 1. So notice this time, this -3 right here, since my variable is now an m, means that now m equals -3. Because we have an m in both places, I am putting this -3 into both of these. So substitute these in, and again, I want to make sure, does this side equal this side here? Okay, if they equal each other, then yes. If they equal anything but the same thing, then it's a no. So we've got 5 times my m, which is -3, plus 9 equals 2 times m, which is still -3, plus 1. So, use your order of operations. Please excuse my dear Aunt Sally. So on the left here, we need to multiply first, then add. So 5 times -3 is -15. Bring down your plus 9. And then -15 plus 9, different sign. So you subtract and keep the sign of the bigger one. Gives me -6. So now I just have to figure out, does this side here also equal -6? So actually, same order of operations. We're going to multiply. So 2 times -3 is -6. So bring down your plus 1. -6 plus 1, different signs, adding or subtract and keep the sign. So that gives me negative 5. Do these equal each other? No. So I'm going to put a little line through this equal sign. That means does not equal. So negative 6 does not equal negative 5. So it's close, but they're still not equal. So we're determining whether my solution is negative 3. So my answer is no, negative 3 is not a solution. All right, so now let's get into actually solving. It says here to solve an equation, use properties of inequality, not inequality, of equality, until the final equation has the form of x equals a number or a number equals x. So you either want something like x equals 10 or 10 equals x. It doesn't matter which side x is on. A lot of times we'll see this, and that's kind of the preferred one, but this one is just as good. So we have two different properties of equality that we're going to go over. The first one is addition. And this is like sometimes very confusing when when we're talking about math and we use letters instead. But basically, if you notice, we're adding c to both sides, or on this one, we're subtracting c to both sides. As long as you do something to both sides of the equation, think of like a scale, right? If you add 5 pounds to one side to keep that balance, you got to add 5 pounds to the other side, or vice versa. If you subtract 5 pounds from one side of a scale, you've got to subtract 5 from the other side. Same concept. Whatever I do to one side of the equation, I have to do to the other. And so even though this says addition property of equality, that still is subtraction as well. So this works for both. And so it says, in other words, the same number may be added or subtracted from both sides of an equation without changing the solution of the equation. What we need to always do is the opposite operation. So what is the opposite operation to addition? That is subtraction. What is the opposite operation to subtraction? That is addition. So these two undo each other. So example 2, we're solving each equation. So the goal here is to get the variable by itself. You want it to be either x equals a number or some number equals x, but you got to get everything away from whatever your variable is. So figure out what operation is happening to that variable. So like in this first one here, we have an x plus 6. So what is happening to that x? To that x, we are adding 6 to it. So we're doing the opposite operation. What is the opposite of adding 6? That is subtracting 6. So I'm going to subtract 6 from this side. Now, what I do to one side of the equation, you must do to the other side. So you'll see a lot of times that other professors or other teachers will kind of put in this little line right here on your equation. That's your scale. That's what you have to keep balanced. So if I subtract 6 from the left, that means I have to subtract 6 from the right as well. So when this happens, 6 minus 6, that is 0. So instead of putting 0, we just kind of cancel that out. Okay, and that's the whole goal, is to eliminate that plus 6. So the only thing I have now is this x over here. So I have x equals, and then over here, 10 minus 6 gives me 4. So that is my solution. Okay, let's try again on B. On B, we have y minus 6 equals 2, negative 2. Okay, so the goal is to get that variable by itself. The goal is to get y by itself. So what is happening to this y? Well, we are subtracting 6 from it. And what is the opposite operation of subtraction? Now that is addition. So I'm going to add 6, but what I do to one side of my equation, I must do to the other side. So if I am adding 6 to the left, that means I've got to add 6 over here to the right. So now, -6 plus 6, that is 0. And so those cancel each other out, right? Because y plus 0 is the same as just y. So we don't need that plus 0 there. So just kind of cancel it out, get it out of the way. So I've got y equals, and now we've got -2 plus 6, so we get 4 again. All your answers aren't going to be 4 though, promise you that. Now a and b have the variable both on the left side. It works the exact same way if your variable is on the right side. Still do the opposite operation. So on C, the goal is to get this variable n by itself. So what is happening to n? Well, we are taking n, we're adding 1 to it. So what is the opposite of adding 1? That's going to be subtracting 1. So even though we're doing this to the opposite side, it's still the same concept. It's still both sides of the equation. So if I am subtracting 1 from the right side, then that means I have to subtract 1 from the left side as well. So now over here, -8 minus 1, same sign. So we're going to add and keep the sign. We get -9. One minus 1 is 0, so that cancels out, and so then I'm left with my n. So I got my variable by itself. Okay, so now this one's in the form of a number equals your variable. Same thing on D. We got -2 equals z minus 8. So what is happening to my variable z? We are subtracting 8 from it. So the opposite of subtracting 8 is to add it. Now, if I'm adding 8 to the right side, that means I have to what? It means I have to add 8 to the left side as well. Got to keep this equation balanced. So -2 plus 8, different signs. So subtract and keep the sign of the bigger one. We're going to get 6. -8 and 8 cancel each other out, so now I am just left with z. Now, if you notice on all of these problems here, the variable was not by itself. So we had to add something over, subtract something over to get that variable by itself. When you look at a problem like E, notice your variable is already by itself. A big mistake that's going to happen is now that we're doing opposite operations, we will take something like this -60 plus 4, and we'll say the opposite of plus 4 is minus 4, and so we'll minus a 4 over, and we get -64. This is not correct. The reason is, and I should not have changed colors, so that's going to make this bad. But the reason is, this is your equation right here. Yes, you are subtracting 4 twice, but you're subtracting 4 on the same side of the equation, not different sides. Okay? So when this happens, and I don't know if I'm going to be able to erase this. Okay, so sorry guys, I can't erase for whatever reason, just like a small little portion, or maybe I can wait. This is why you're supposed to, no, that's not it. I don't know how to erase. Ah, there's some. Okay. Well, I'm just going to have to erase it. I'm sorry. So if you need to look at D again, you're just going to have to rewind the video. Okay. Or I can just do this really quickly, I guess. Okay. So I'm going to try to do this without needing to waste your time. So like I said, you can't subtract 4 from both of these, saying the opposite of plus 4 is minus 4. Cancel those out, and we get x equals negative 64. Bring down your plus 10, because notice you're doing the same thing to the same side of the equation. So this is not balanced whatsoever. When you have things on the same side of the equation, simply simplify. Okay, you're not doing the opposite. You're not moving something from one side of the equation to the other. You're just combining. This is regular old math. So, negative 60 plus 4, different signs, so subtract and keep the sign of the bigger one. We get negative 56. Bring down your plus 10. Same thing. They're on the same side of the equation. So combine your like terms. Different signs, so we subtract and keep the sign of the bigger one. We get negative 46. Okay, notice the difference is on E, all of your stuff is on one side of the equation. You already have your variable solved for. So there's nothing to move around on one side of the equation to the other. Just combine. Just regular old adding and subtracting. Okay, and that's going to be the biggest kind of hurdle until we get really good at this stuff. Okay, objective C, now we're using multiplication of property of equality. Same concept. If I multiply something to one side, you've got to multiply to the other. Or if you divide both sides by something, you've got to divide it to both sides. And again, notice this says just multiplication, but this works with addition too. Okay, addition, or no, not addition. Multiplication also works with division. So you have this multiplication property of equality umbrella. It includes multiplication and division. So it says right here, in other words, both sides of the equation may be multiplied or divided by the same non-zero number without changing the solution of the equation. We are still doing the opposite operation. So the opposite operation of multiplication is division, and the opposite operation of division is multiplication. Okay, so figure out what's going on with your variable. Is something being multiplied to it, then divide it. Is something being divided, then multiply it. Opposite operation. Okay, so on A, solve each equation. We've got negative 5x equals 15. We need to get x by itself. So what is going on between this negative 5 and this x? Now, a lot of times I hear they're being added together or they're being subtracted together. If they were being added or subtracted, you would see a subtraction sign or an addition sign. Therefore, what that means is these are being multiplied. That's negative 5 times x. The opposite of multiplying is dividing. So I'm going to divide by negative 5. And what I do to one side of this equation, I am then going to do to the other side. So negative 5 divided by negative 5 is 1. So technically we have a 1x, but we don't really need that 1 in front of that x. So we just cancel those out and call that x. And then over here, 15 divided by negative 5, different signs. That means we get a negative number, so negative 3. Okay, on B. Goal is to get this x by itself. So, what is going on between this x and this negative 20? That little bar here means that they're being divided. The opposite of division is multiplication. So I'm going to multiply negative 20 over here. What I do to one side of my equation, I must do to the other. So if I multiply the left by negative 20, I need to also multiply the right by negative 20. So, just like over here, a negative 5 over negative 5 is 1. Negative 20 over negative 20 is also 1. So these cancel out. So all I'm left with is this x. So we get x equals 3 times 20 is 60. And negative times negative makes a positive. So that is my answer. Okay, same thing on C. What is going on between x and that 3? This bar right here tells me they're being divided. The opposite of dividing by 3 is to multiply by 3. And what I do to one side of this equation, I'm going to do to the other side. So I'm also going to multiply this side by 3. If you multiply the left by 3, you got to multiply the right by 3. So your 3's cancel. We're left with x equals, and negative 4 times 3, different signs. So that's negative, and 4 times 3 is 12. On D, what is going on between my variable y and that 3? If I don't see a bar, if I don't see an addition, if I don't see a subtraction, the only thing I got left is multiplication. That is 3 times y when they're side by side right next to each other. So the opposite of multiplying by 3 is to divide by 3. Hopefully you're tired of hearing me say this, because if you're tired of hearing me say this, then you've got it. But whatever I do to one side of this equation, I have to do to the other side. So if I'm dividing the left by 3, I must divide the right by 3. My 3's cancel. 3 divided by 3 is 1. 1y is the exact same thing as just y. So I get y equals negative 18 divided by 3. It's going to give me a negative 6. Different signs, so it is negative. Okay, and if you want to pause this video and see if you can do these last 4 on your own, I highly encourage it. But on E, we're doing the exact same thing. It doesn't matter that my variable is on the right. Still get it away from the variable. So on E, what is going on between my 3 and my y? The exact same thing that was going on between this 3 and y. They're being multiplied. Opposite of multiplying by 3 is to divide by 3. And if I'm going to divide the right by 3, then I have no choice but to also divide the left by 3. So over here, negative 27 divided by 3 is negative 9. So we get negative 9 equals, my 3's cancel. 3 divided by 3 is 1. So we're left with y. On F, kind of wrote over that. but that is an x. So we've got x over 5 equals 2. This bar right here is telling me I am dividing by 5. The opposite of dividing by 5 is to multiply by 5. And what I do to one side of this equation, I must do to the other side. So I'm also going to multiply by 5 over here. So my 5's cancel. I'm left with x equals 2 times 5 gives me 10. On G, goal is to get x by itself. So what's going on between that x and that negative 12? If they're side by side, they are being multiplied. That is negative 12 times x. So the opposite of multiplying by 12 is to divide by 12. And what I do to one side of this equation, I've got to do to the other. So if I divide the left by negative 12, divide the right also by negative 12. My negative 12 over negative 12, those cancel because that equals 1. So I'm left with x equals 12 goes into 36 3 times. And negative over negative does turn to positive. So we get x equals 3. And then our last one. Goal is to get this x by itself. So this bar here tells me we're dividing. So the opposite of having an x divide by 4 is to multiply. And we need to include that negative with it. What I do to one side of this equation, I must also do to the other side. So I'm going to multiply this side also by 4. Sorry, negative 4. So over here, negative 4 times 7 gives me a negative 28 equals negative 4 over negative 4 cancel each other out. So we're just left with x. And if you kind of notice, these two here both have the number and the x backwards. I've had some teachers really care about which one comes first. I'm fine with this negative 28 equals x and negative 9 equals y. But if you do want to switch it, you can make that x equals negative 28. Okay, does not matter. You can also make this one y equals negative 9. You can switch those up, just so you guys know. And then our last page. This is a review from section 1.8, which was the second lecture we did, second lesson. Translate each phrase into an algebraic expression. Use x to represent, in quotes, a number. Excuse me. So it says the total of a number and 5. And negative 15. Whoa, way off. Total here is a hint word for add. So we're adding a number and negative 15. So I've got x plus a negative 15. 7 decreased by a number. Decreased means minus. So we've got 7 minus some number. We're calling some number x. The product means to multiply, so you need to put an x or a little dot, whichever one you like. The product of a negative 20 and a number. So we've got negative 20. I'm going to put the dot times a number since we're having to use x here. Now this one is technically just good. I mean, just fine. You can have negative 20 times x. But really and truly, we need to get in the habit of not only writing it this way, but also seeing it this way. That more simply, we need to, this is a negative 20x. Right? No operation. That means those are being multiplied. And then quotient means to divide. So the quotient of a number in 6. So you can write this one 2 ways, and both of these ways are perfectly acceptable. We have a number and then -6. So you can either do your number divided by -6, but you're going to start seeing this more often as a fraction. So x over -6. These mean the exact same thing. Rewind this video, pause it as you need to. Let me know if you have any questions.